Hello everyone, welcome back to the series. Today we are going to talk about, we keep reading Laravel, and the topics will be the application bootstrapping. And to do that, of course, we will have an overview of the application, what's the application doing and the concepts behind it. And to do that, we need to understand the container and how it helps the dependency injection. And we will cover those topics when we get there. And then we will take a quick look at the application builder, because that's a good, and by the way, I had to go through the code prior to the session so I could get my mind around what's happening there. So it's not entirely new for me, but of course it's going to be a little bit of a challenge to describe in words what I understand from the code. And we are going to use the app builder to just try some examples of how we can do things differently, and we will get there when we reach that stage. But that's the idea for this episode. So let's start by going to, we were into the index, right? And here we have this, we cover all those files, the autoload and the maintenance files in the previous videos. And this one here, it's where we will start today, and it's the bootstrapping. So if we open it, it's inside bootstrap folder, and there's a folder just for bootstrapping. And the folder for bootstrapping, it also has some caching and the bootstrapping of the providers. And I think those are meant for your application to change them. So for example, if you want to bootstrap the application with more providers, you can do from here, I think, but we can cover that when we reach there. So let's just open the app.php, and that's where everything starts related to the application, right? So it includes, not includes, but it's using the foundation application class. And because it's the purpose of this bootstrapping, it's to get us a new application object. See, in the end, we will receive, well, not we, but the index will receive a new application object, instantiated and configured for us. So let's first understand what the application is, right? Because it's a word, of course, and it's a concept, the application. And you might imagine that the application knows things about paths and configuration and things like that. But Laravel also implements something here that the application, it's a little bit more than that, right? So let's take a look at the file, because if we do that, I think it's easier to follow and explain what everything, not everything, but the concept of application, right? So that's the file that's being used here. So that's the one that's has the configure method, right? So this file here, if we take a look at just the class, right, and what it's extending and what is implementing, we will see that the application extends a container. This means that the application is also a container, but it's a more specific type of container, right? So the first thing, what's a container, right? And in the case of Laravel, of course, because we are definitely, there's more. The container, it's just an abstract idea, right? Something that contains something. But what is a container for Laravel? So we can take a look here, and this is the class that's probably implementing the container. So we do again container, not conditionable, container, yeah, container, right? So that's the container that our application, Laravel application, sorry, not our application, Laravel application, it's extending. And we can see here that the container implements array access, and this is just a interface, I think that coming from PHP, that makes objects, that implements this interface able to be accessed like an array. So we can test that, but that's that. And then the container contract, right? The container contract, it's created by Laravel. It's here, right? And I think this is just to make it easy for extending, or even to make things organized and make things also easier into the rest of the application. You can reference to this interface instead of an actual implementation of it. So when it's time to, I don't know, create another container, you can just switch the actual implementation and not change anything in the code that's using that. But that's the idea for interfaces anyway. So that's why I think they created. So let's take a look at the interface first, because the interface, it will be less convoluted. Not saying that this class is convoluted, but it doesn't have the implementation details. So it's easier for us to just get a sense of what's a container, right? So we go there, contracts. Oh, by the way, contracts in Laravel world, they are just interfaces, right? They call contract because it's something that the class implementing that contract needs. It's like you were signing a contract. You have to do the things that the contract it's saying you to do. So that's, I think that's why they call it contract. But I think it's just the interface, right? So container, and then container again, right? Yeah. So that's the interface for the container. And you can see here that the interface for the container also extends another interface. And that interface, it's not from Laravel or from Symfony, etc. It's from here, from the PSR project, that they define, basically they try to define a set of rules to develop in PHP to help code get more organized, etc. I think that's that. So they defined an ideal container interface, right? And if we take a look here, I think it's container, yeah. See, it's just interfaces, and the container interface, it's just get and has. So a container ideally would have a method for you to get things from out of the container, right? Ideally, the container contains something. So you want to get something, you get by ID. So that's what this interface here is defining. You will get things by ID. And it's also saying that you should, in the documentation, saying that you should throw exceptions when not found. And if there's an error, you should throw another exception as well. And those exceptions are also implemented, well, not implemented. The interface of them are in this project, in this PSR container project. And the second method of this interface is the has. So you have your container should to be compatible with this interface. Your container should have a has method to tell whether the container has that item or not, right? So it returns a bool. So that's it's pretty simple. This interface from the PSR project. I think that Laravel, it's just implementing it to be compatible with that set of rules. So that's why this container interface from Laravel is extending the PSR project, and probably, of course, our container object that's implementing the container contract must have function has, right? Yes, it's here, and must have the function get as well. Yeah. So let's take a look, an overview of what the container is. So the container, it has a bound method, and this is Laravel, to tell whether something was bound to this container or not. And bound, it's just to check, probably it's a similar thing, I think, from the get, not the get, but the has, right? And let's just find the bind here. Yeah, there's a bind method. So if you want to, I think, associate things into this container, you use this method, bind, right? And there's a possibility for you to also use tags. So you associate your items to certain tags, and you check if there's any associated item to a determined specific tag. And what else? We have the bind method. Okay, you can bind callbacks, right? You can bind conditionally, singleton. It's a concept you guys probably know, of course, but when you have an object that you want to use throughout the entire application, just that object, no other instance from the class that the object, from the class of that object, you just want to use one instance, then you have a singleton. So you can also register a singleton item here, and we will take a look. I think the others are scoped, right? This is more if you want to register something that has a scope. Scoped if extend an abstract type in the container. Oh, okay. Right, so you can register that as well. Instance, okay, a specific instance, and those things are going to make more sense when we discuss, of course, what the container contains in Laravel, and that's in the docs. But we can check here in the code as well. So let's do just a test. So enough of talking here. Let's do a test before we have an application, right? So we don't care about this for now. Well, actually, let's just do that, right? And we will instantiate our container. I don't know if that's going, I think it should work, right? It's not an abstract class. Let's check here. Yeah, it's a class. So we could potentially do this, eliminate, it's foundation or not, it's container, yeah. So container, right? And the constructor has any, no, there's no constructor, right? So we could potentially do this and do a die dump container, oops, and check what's in here. We have an error. Oh, of course. Yeah. Okay, so we have the container and we have all those properties related to the methods that we were checking, right, in the interface. But so far, it's just what it contains, right? So for the purpose of the app, right? So the app is a container. And that's a good question. Is that really specific to the current globally available container, if any, resolved bindings? Yeah, so it's kind of already, it's not a generic container. I think it's already moving towards, it has details like scoped instances. So when you say instance, you already refer to instance of a class, objects, right? So I think it's more like a container of classes and objects, right? Types and instances. So our container could do something like this: container bind, and I can bind a certain class here. So I don't think I have. Do I have any model? User. Okay, yeah, I do. So yeah, the model, I'm not sure if it's a good example, but let's try that. App models user class. So I'm telling the container to bind this class, which means the container will have that into the bindings collection, right? So if I do bind here, I can bind something just by the abstraction, and the abstraction here, it's the class, right? And I can pass also a concrete, which is just an instance of that class that I want to use whenever I get from the container this abstraction, right? But right now, if I just pass the abstract, I think I will get an empty user object instantiated for us by the container, right? Because I think the container has the make as well, right? Should do function make with make. Yeah. So let's do that. I'm binding the user, all right? And then I want to get the user from the container. Container make, and I need to tell, okay, container, give me an instance of this abstract, but which abstract? So the abstract is the user, right? Class. So that's the key. And if we go back to the PSR interface of a container, get and has, this would be similar to the get, I think. And we can test also the get later, but let's do this first. So if we do a dd here, user, okay, so you can see that the container works just by himself. It knew that I had a user bound to itself. So when it was asked by a client code to make a user object, it knew what to do because it knew the class, right? But that's not very useful if you want to have, if your class has some dependencies, right? And by dependency, I mean your object, your class, has needs to receive an ID, for example, just like a user, right? A user might receive an ID, Or let's do something different. Let's create a app, our test object, something like that, just to, and the namespace will be app class test object, and our constructor will receive, sorry about the noise, neighbors. So the constructor will receive an ID, let's say ID, right? And we will get this ID equals to ID. So the private ID, and that's it. We don't need anything else. So imagine I wanted to register into my container my test object, right? So I will do that here. I will say test object, and then I will ask for that test object. But also I want to make with an ID. I want to pass an ID to my test object, because if I try to do this here, I think it will fail, because my constructor, it's requiring an ID, and this container here doesn't know that which ID I need to pass, right? It probably knows from reflection, and reflection is just a PHP functionality to know information about methods and classes, etc. So it knows information about the code. So if a method has parameters, then it knows which type of parameters, the names of the variables, etc. So I think that the container might know even that the test object constructor has a parameter. It needs a parameter, but it doesn't know what to pass, right? So I think if we do this test object, it will fail probably. Yeah, we have an error. If we open the log, photo error, binding resolution exception, unresolvable dependency resolving parameter 0. So, and required ID. So resolving means it can't pass the parameter, right? Because it doesn't know. So there's no way to solve this issue. So, and dependency, it's because to create our class, we need an integer ID, right? So it's a dependency. So that's why it's calling dependency here. So you can see now that the make with, it's very handful, it's very useful, because you can pass, oh, somebody in my daily in my daily game played. So I can pass 1, for example, right? And then I think we will be able to var dump this die and dump. Oops, there's something wrong. Make with class 1. Let's see the error here. Load. Resolvable dependency resolving parameter 0, the same thing. Container make with. It's not make with. Make with, yeah. Parameters. Should we pass the name as well? Make, and resolve. Let's take a look at the implementation. So function resolve. Resolve the parameters. Is it reaching here? Parameters. Yes, it's reaching there. But how does it handle the parameters? Parameters. If raise events, no, we're not probably raising events. No, it's raising. Okay, fire before resolving callbacks, but maybe that's not. Needs contextual beauty, if not empty or not null. So we need contextual beauty, definitely. If it's set, and doesn't need, no, so that's not the case. Share and doesn't need, also not the case. Right, concrete, abstract, this with parameters, so get concrete. Maybe it's here, right? Function get concrete. Get concrete. Sets binding abstract concrete. No, this was ready already. Instances. This with parameters. So this with, it's with our parameters, right? Yeah, but with 0, 1, okay. I think get concrete is buildable. Build, maybe that's it. And what's this concrete here? Concrete can't be the class, right? So it's a closure. Oh, okay. Right. So it might be here in the build. We are ready to instantiate an instance of the concrete type register for the binding. This will instantiate the types as well as resolve any of its nested dependency recursively until all have gotten resolved. Okay. So it's probably one of those build instance. Yeah, so it get the constructor. Our constructor might be here. Reflection method. So you can see that the reflection knows about the parameter, knows the name, etc. So maybe it's using the name. It's even if there are no constructors, which in this case it's not true. Dependencies. Okay, we will have our dependencies probably here, which is just a dependencies. Right. So the ID. Okay. Once we have all the constructor parameters, we can create each of the dependency instances. Oh, because it might be an object, right? As well. So the resolve dependencies might have to instantiate other objects. Nice. Yeah, that makes sense. This parameter has parameter override, get parameter override. If the dependency has an override for a particular build, we'll use that instead of the value. Right. If the class is null, it means the dependency is string or some other primitive. Yeah, which we cannot resolve since it's not a class, and we'll just bomb out with an error since we have nowhere to go. So we can't pass a primitive. That's the problem here, right? Well, let's take a look at the documentation, because I'm pretty sure you can make with an ID, for example. So let's just act it to your service container, binding basics, make with. Okay, so you need to tell the name. Oh, I see. Right, it doesn't matter the order, I think. If the thing we are trying to pass, if the dependency is a class, then the reflection can know where that class should be used as a dependency in the constructor, right? Because it can check the type of the object. But if it's a primitive like this, there's no way to resolve, because there might be more than one integer, so where it goes. So that's why we have to do probably this, and then it can resolve, because it will check not the type but the variable name, probably. Well, we have to remove our DDs from the application here. Oops, DD like that. Okay, so we just removed. Yeah, and we have a test object here now. Okay, nice. So we tested the container. Container makes sense, a little bit more sense now, but why is that important, right? We can test this, not test, but see that in action here if we move forward a little bit. So let's just make sure this still works. Save. Yeah, it still works. So let's just keep that in mind, that the application, it's also a container. So the Laravel application might contain classes and concrete implementations. Well, they call types, right? Concrete implementations for the types, and that can resolve dependencies also for those types. So if you bind a class like ours that had a dependency, meaning a constructor parameter, right? This container, meaning the application as well, will have the ability to resolve those things when you ask for an object of that type, right? So it's a tool to help managing the dependency injection. So the container injects the dependencies into the objects that it's creating automatically. And of course, it needs to be able to do that if you bind the correct information. Like if we try to make with parameters, you have to pass the parameter names if the parameter is not an object, etc. But other than that, that's what the container is. And the application is a container. So you can expect that behavior from the application, from Laravel application. And then the rest here, it's just implementing a few extra functionalities. So this application, on top of being a container, it's also an application, right? Because it implements an application contract, an application interface. So let's just quickly take a look at that. Source here, eliminate, contracts, foundation, and application, right? So that's the application interface. And the interface for this application is very simple. It just provides methods for the client code to get the version of the application, the base path, the bootstrap path, which is bootstrap, right? The config path, a lot of paths that are needed for the application. It also gets the environment, check if it's running console, running unit tests, a lot of things generic, right? For an application. If it's in the debug mode, here our question, right? Somewhere else in the code, the system would have to handle the maintenance mode as well. So here are some tips. The application knows about that. So it knows if it's down, it gets an instance of the maintenance mode manager, right? So that's the start of that question that we had in the previous videos. We can register provider's configuration, right? We can register, oh, okay, so that's not related to the container, I think. It's just registering service providers, and we'll take a look at that when it comes the time. Oh, and this is also resolves provider instance from the class name. So it's doing kind of what the container does. And I'm curious, maybe this is using the container. Let's just take a look here quickly in the resolve provider implementation. So resolve provider, because it would be silly to not use, right? If it's the same function. New provider this. Okay, because the providers all have already very specific dependencies, which is just the application. So you can see it's passing the application itself. It doesn't need a very clever dependency system, right? Dependency injection system. It's just injecting the only one, which is the application itself. Okay, makes sense. So all those things like booting, booted, all those things are things you expect from an application to know, right? It's on locale, it's on namespace. There's the terminate function here. And that's the application. So we can think about now the Laravel application as a container, but also, of course, an object that knows details about the application itself, like paths, knows the status, the states, and the providers, and a lot of those stuff. And on top of that, it also has access to configuration and routes caches. I think this, and I take a look at the in the interface here of those two contracts. The naming, it's a little bit misleading, I think, because I thought that this was responsible for caching the configuration because it caches configuration, but it's not, maybe because English is not my first language, but I was expecting this to be a verb like caching something, but it actually, it's just, it has access to the cache, right? So the configuration cache, it's put somewhere else, I think, but this application has access to it. So we can just take a look quickly. Cache configuration, it's where? Caches configuration, it's eliminate foundation contracts, caches configuration. So you can see it knows if it's cached or not, get the configuration cache path, and get the cached information, right? But it doesn't create this services PHP file, because also the service PHP file it's already created. I think it's in here, right? Bootstrap, providers, cache, services. So it's already put, and I don't think it changes things dynamically. I think that cache should be changed by the developers. Developers working with the application should add things into that cache, right? So yeah, that's that. And I think that the cache routes, it's the same thing. Similar cache routes. Knows if the routes are cached and get the routes path, the cache path, right? Okay, and the last thing, and it's important, it's last, but it's important, it implements the kernel interface. And this HTTP kernel interface here, it's from Symfony. And the only thing it does, but the only interface it has, if we go to, well, actually it's not, sorry. Yeah, I'm getting ahead. This HTTP kernel interface, it's from Laravel, and we can take a look at that here. So contracts, HTTP, kernel. So you can see it's the kernel interface, and kernel interface. Oh, no. So I was right. Yeah, it's from Symfony. I saw this kernel contract here, but that's used elsewhere. So yeah, the application, it's directly implementing the Symfony kernel interface. So let's take a look at that. Vendor, Symfony, component. No, it probably, it's going to be kernel, and it might be here, right? Kernel interface, yeah. So that's the interface that Laravel application implements as well. And the only method here, it's the handle method. And the handle described by this interface handles a request to convert it to a response, right? So it's basically the entry point of any operation that the application is doing. I think that's why this application implements it, because the application needs the start point of the processing of the request. It's not processing the request by itself, but it's delegating that to the kernel, to the correct kernel. If it's a request coming from the browser, it's one kernel. If it's a request coming from a command, it's another kernel. So the kernels are responsible for handling that, I think. And the application, it's just delegating that. But it needs a proper interface to do that. And Laravel application implements this. I'm not sure why exactly now, because it's not the one it uses. If we can take a look here in the index, it's not handle, it's handle request. So if we take a look now back to the application and call handle, it does implement the Symfony interface, of course, because it's implementing that. But it's doing something very similar here, handle request. And it's similar in a way that it's not making the kernel, right? It's getting the kernel directly from the application, probably a concrete associated with this already, because it doesn't allow the application, the container, to resolve dependencies, probably because it's getting like it's an array, right? So if we do, what can I do if I do this? I could just do that up there, but, and I call this method, instead of handle request, we call handle, and it needs a Symfony request. Probably this Laravel request is also a Symfony request. We can test that, but I think it is. So it would accept this. Yeah, accepts that and reaches our die dump. And this is a kernel object. And if we go back here, yeah, it's an eliminate kernel. So it gets that without having to resolve anything. So I think that's the difference here, but I'm not sure why this method is here. Maybe because Laravel is used a lot for, and it has a lot of years of development, right? So who knows, this might be the first thing that they did and they switch it to this one later on. So I don't know. I just think that this is less flexible, because this one is using the container to resolve this type here, right? So that scoped thing that we discussed, maybe the kernel contract has a scope. So depending on the environment, depending on the scope, the container provides a different implementation. So for example, if it's a command line request, it will provide the kernel from the command line. If it's a browser request, it will provide an HTTP kernel. So yeah. Well, actually, this is a HTTP kernel contract. So yeah, I don't know exactly, but in any case, application is also the entry point that handles the request. Of course, it doesn't handle by itself. In both cases, it gets a kernel and delegates the handling to that, right? But in here, for example, it also terminates the kernel. The kernel has this call terminate here, and here it doesn't, right? So not sure why, but Laravel is implementing that Symfony interface anyway. So let's just go back here. I don't want that, right? Our application can run freely now. No, we can't. And the request doesn't exist, of course. Right. Okay, so we took a look at the application and what it is conceptually, right? It's a container, contains methods, contains types, and it resolves dependencies to make those concrete objects from those types. It also implements the application contract, has access to cache, configuration, and routes, and implements the kernel interface. Right? So that's the application. Now, what Laravel does here in the bootstrapping, we can take a look at that. Let's just remove that test object here. It's calling this configure method from the application, right? And application, it's here, configure. And what this is doing, it's a static method, just, well, first checking if the base path passed is a string. If it is a string, then it associates the base path to this variable. If it's not a string, or if it's null or something else, then you use the default value, which is infer base path. And this infer base path is just getting the base path from the environment, like this, if it exists. And if it doesn't exist, it tries to get from the composer, because the composer class loader, it knows, it registers the loaders. Remember, we discussed that previously in the previous video. It registered the loaders, the class loaders, with a key, and the key, it's the path to that file that registered the loader. So the composer has the base path of the application already. And I'm not sure why Laravel tries to do that. Yeah, I can think of a case where this would not receive the path, because see, configure base path, the name. But again, this configure method might be used elsewhere as well. I checked, not in here in Laravel code, but maybe by some other code using Laravel. So that's why they might be doing this. And we can't understand everything because we don't know the use cases, but that's what it's doing. And the important thing here, I think, it's that the configure method instantiates a new object based on this application builder, right? And it's just the application builder, it's just a class that helps building and configuring the application itself. So you can see that the application builder has a dependency, and the dependency, it's the application itself. So that's why the configure method, which is a static method. It's instantiating application, which is this class, and passing it to the application builder, because the application builder needs the application to set kernels, events, commands, and providers, the basic stuff, right? So this is a good opportunity for us, and that's the final part, I think, of this video, to test how we could use the container to demonstrate the good things or the advantages of using a container, right? Because, and I'm pretty sure the developers of Laravel, of course, they thought about why they wanted to create a static method with a dependency inside, like being hard coded here, because this configure method, it's dependent on the application builder. So application class depends directly on the application builder, and the application builder knows a lot of details from the application. So it's a close dependency. And I'm sure the developers thought about that, and they thought that this was better than the other alternatives, because probably it's a method that reads better when it's here, and it's very, it's really just used in one place, and the relation between the two classes, it's close, but they are not used, well, at least the application builder, it's not used elsewhere. So probably they thought about the pros and cons and decided to do this. But to test the container, we could try to just revamp this in a container way, and you can see the advantage. And I can tell one of the issues here, if of course the developers wanted to build an automated test for this method, it would be how to isolate this execution, right? Because when you test, you want to really test just the thing you were testing, not remove all the dependencies. And how you remove dependencies on tests is using mocks objects, right? So you create an object that looks like the one that you need to use, but it's just an empty object that counts how many times methods were called and can report back on that. So in this case, we would need a mock object for this application builder to know if the configure method it's correctly calling with kernels, with events, with commands, and with providers one time only. And that's it. That's the test, because that's the logic. And it's not actually a logic, but the logic, it's more like if here. But if we want to really test, we would have to test, of course, if those methods are still being called from the configure method, right? And right now, doing that, it's possible, but it's a little bit harder because you can't really isolate. You would have to call this configure method, get the application builder, and the application builder would have to be a real object, because you can't really tell this method to use something else, right? So you would have that dependency that if the application builder breaks, your configure test might also break, right? And that's not ideal for testing. So we can go back here and take a look. Okay, how can we solve that? We can solve that by injecting the dependencies, right? And that's the nice thing about the container. We could also do this, app builder, and app builder equals new app builder, blah, 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 etc. So we instantiate our dependencies outside, and the method will receive the dependencies. That's one way to inject, right, the dependencies, but it's not a very It's not a very robust way because you would have to instantiate the dependency yourself each time you use. And in this case, of course, it's just one time. It could be okay. But we want to use the container because the container can do all the work for us. And if you want to swap things, you can just do work with the container, right? So let's use the application itself, because the application is a container, right? Let's use the application itself to contain our application builder. And then let's make the configure method use the application, meaning use itself, to get an instance of the application builder. And then you will see that we will be able to test, if we wanted to, this method, right? So let's start by just instantiating a new application, right? So we need that. The application is our container. So we need that here. So we have the app, and I passed the base path because if you go to the constructor, it's a dependency. So, okay. And now we have our container. What we need to do, we need to bind our application builder, right? Because the application builder will be available there then. So the application builder, it's eliminate foundation application, I think, right? Foundation configuration application builder. Configuration application builder, right? Class. And I don't think it has any, oops, not Symfony, but Laravel, foundation configuration application builder. Yes, it does, of course. It does have a dependency, and it's the app. So we can leave it here, because when we are making that application builder, we can make with, right? So no need to bind any different from what we have now. So we are our app. So what we do, we don't have to call the configure method statically anymore. We can do just configure, right? And here, that's the application builder. Here, our configure won't be static anymore. Won't need the base path, because the application already has the base path. And please, I'm not going to pull request this. I know it might be breaking thousands of use cases that I'm not aware of. So I'm just doing this to represent, to get an example of how we can use dependency injection using the containers. All right. So here, just to make sure we keep a little bit of the logic, we just have to test if this base path, there's no base path, we give a chance for the application to set that base path equals to the infer base path, right? And with that, we just have to, now we don't need to manually instantiate a new application builder. We ask for it, right, from the application itself. So we could do this, make with, we want this, right, and class, and make with. And now, because we are passing an object, we don't have to name it, because the resolve code will be able to find it, right? We learned that. So And that's the nice thing about reading the code, because you remember things much better when you read and test compared to reading the documentation, right? Of course, I'm not saying we should all read the code, entire code of things we use, but to learn it's much more efficient. So we pass this, right? We need the app to instantiate the application builder. So we pass this, and with that, I think we can remove this because we're not calling new anymore. Make with, I make application builder with the application itself. Then I can keep calling those things, right? And in here, I created an instance of the app. I bound the application builder. Then I just call the configure, and I keep calling with routing, etc., because this configure method returns the application builder, right? That's why I can keep calling with routing, with middleware to allow, and remember this app file, it's inside the application code, meaning the developer might have a chance to add middlewares here and exceptions, etc. I think that's the purpose of this, right? So let's take a look if this works. Yeah, it works. If we try up, for example, still working. So we just demonstrated now, because the dependencies are being, they are not hard coded in here in the configuration. How can we test? It's easier to test because the only thing we need, like real in the test, it's the container. And okay, it's silly because the container is the application, so you would need the application which you want to test to be a real thing to work, to make this test to work. But if we are doing, it's an example, but if we are doing all the other areas of, we're testing all the other areas of the system, we will have a way to inject the mocks that we want to be able to test things better. So in this case, if our test code would do this, would create an application, would bind, instead of the real application builder, would bind a concrete here. So you can bind and pass the concrete, remember? And the concrete would be an instance of our mocked application builder with the app already, because we are instantiating it. And then when we call app configure, this method would work with our mock object and not the real application builder. Because when we call make with, actually make with, does it work with? Let's test that. We want to bind, that's the final thing. Builder, we want to bind this object, app, right? Oh, missing the new here. So builder, that's the concrete for that. Okay, does it still work? Because make with would have to know, okay, I have a concrete. I think it does check that. I think we checked. No, it doesn't work. Let me see if I did something wrong. On card type, error, container bind, argument 2, concrete must be type of closure. Oh. So let's just refer back to this binding interface to implementations. Bind class. Oh, right. Okay, I need to do this then. Closure function return no, and this should receive use app, right? And then we pass the closure. Yeah, it works. So Laravel, it's smart enough to know the concrete it's already built. So when it calls make with, it just doesn't bother. I think it just stops from when it found the concrete already, right? I think we saw that code. But anyway, we won't go there now. We checked how the bootstrap it's working. We understood the application. We understood the container, which is a very important thing. Of course, we'll see more usage of that when we keep reading. And we saw the application builder. We didn't take a look inside of that too much, but we can do that when we go over those methods. But I think that needs to be in a different video. This one, it's too long already. So I hope you enjoyed, and we will talk soon. Bye-bye.